Everybody, and welcome to our case study on this 2014 Cadillac SRX with an airbag light on. A little bit of history on the car. Came to us from another shop. Apparently, it originally went in with a airbag light on and a code in it for the driver's door crash sensor, which is nothing more than a sensor that detects impact on the door. Apparently, during the course of the repair, they replaced the sensor, so it's got a brand new door sensor in it. And when after they put the door sensor in it and powered the car back up, they not only had an airbag on, but now they had a code for the left door sensor and the left front crash sensor. So the problem actually got a little bit worse after they diagnosed and did the initial repair on it. But the first thing we're going to do with this car, pretty straightforward, is we're going to hook a scan tool up to it and see what the codes are. All right, so we've got our scan tool hooked up to it. We've gone in and identified the vehicle, 2013 Cadillac SRX. Going to go in and do a quick check for trouble codes. And when we go in, we see the trouble codes. Now, we're showing a code for the left front impact sensor. This is the left front impact sensor. This is in the front of the vehicle, sort of in and around the left front headlight area. And then we have the code for the side door impact sensor as well. Now, this vehicle, when it came to us, it had some issues with the PCM connector. Those issues have been repaired. Now, there's also, if you go into the special function menu on the scan tool here, there's also a function that allows you to configure a new module. The module on this vehicle has been replaced. We're not sure whether they did this routine or not. So before we get too far into hooking up a lot of test equipment, that kind of stuff, I think the first thing we want to do is make sure or try and run this configure new module routine. So we're going to go ahead and do that. So when I push the configuration button on my scan tool, I get this configuration mismatch, and it lists a bunch of things here that it could possibly be. But when I hit the continue button and I go to the next screen, it says basically this procedure can't run until we clear all the DTCs. So we can pretty much guarantee that this module is not configured properly. And the reason it's not configured properly is because it's got DTCs. So no matter how we go about this thing, the first thing we have to deal with is the DTCs that are stored in this thing. So our first step is to grab a wiring diagram, take a look at how these sensors are wired up, and then see if we can determine how we're going to go about testing them. This is a wiring diagram for the front impact sensors, and I chose to kind of pick on this guy right here. Sorry, not that guy. Where is it? Front impact sensor, left side. And the reason I did this was pretty simple. It's out in the open. I just had to take one cowl cover off with a couple of plastic clips on it to get at it. Whereas if I wanted to do the side impact sensor, this guy, I would have had to take the door panel apart. Now, obviously, I'm going to have to take the door panel apart at some point to go in there and actually fix it. But since both sensors are kind of logging the same type of fault, I decided to do the bulk of my testing on the easiest one to get at. Now, when I look at the wiring diagram here, it's pretty straightforward. This guy is a ground, and this is the signal wire, probably also the test wire. So what I'm going to do is I'm going to hook my scope up to this thing, and I expect on this wire that the PCM will put out some kind of a voltage-based signal or pulse or something like that to check the integrity of the wiring. and the circuitry. Obviously, if there's a fault, we're going to see something. And then what I'm going to do is I'm going to literally compare the signal from this guy to the signal from this guy. This guy's not sending codes, the right front. So we know that we can use that as kind of a baseline for what normal looks like. And then we can go over to the left front and see how close we are to normal. Now, the reason we're doing this is when I go in and look at the service manual procedure for testing these circuits, they basically have you run some continuity tests on the wire to make sure the wiring is intact. And if the wiring's intact, then basically you are to replace the sensor. Both of these sensors that are setting codes are brand new. So we know that that's kind of a false trail. So I decided to sort of go over and above what service manual will tell you to do here and just kind of test it my own way. So the next thing we're going to do is we're going to hook up their scope, and we're literally going to hook up a scope lead here and a scope lead here, and we'll just compare the two signals and see how close they are to each other.
So this is a setup that I use to scope the signals. You can see that it's a bit of a mess, and the airbag module itself was kind of in a tough spot. You can see that we've got the center console sort of torn out of this thing. The airbag module generally sits down in this area right here. I decided that I was going to pull it up so I could get at the connectors and the pins easier. You can also see right here where they've repaired some wiring on this thing. And yeah, so I think the next thing we're going to do is scope from here out to the actual crash sensor on the left front.
All right, so here is my scope shot. Basically, this was taken at the airbag control module, kind of like what you saw on the previous screen. You saw how I hooked it up. I'll explain the wires here. This blue wire is literally the ground for the airbag module, and it looks all right. The yellow and green trace down here are the sensor grounds. Again, they look okay. Up here, the red trace is the right front, and the purple trace is the left front. Obviously, there's an issue here with the left front. The right front appears to come on. This is me cranking the car to start it up. You can see here that the red one, the right one's not setting any code, so this would be a normal voltage pattern. You can definitely see that the voltage pattern is different on the sensor that's setting the codes. So what I'm going to do is I'm going to just kind of zoom in here and take a look. Obviously, the computer's seeing something here it didn't like. Tested it a couple of times, and then it literally turned the light on, set the code. So I'm just going to kind of zoom in on this to get a little bit closer look at it. And I'm going to zoom in a little bit tighter. Now, I don't really see anything different in these two patterns. They both kind of turn on at the same time, one slightly ahead of the other, which just be the computer's turn on sequence. And then this would be the test pulse. The bias voltage on both of these guys is sitting at about 6 volts. Same thing with this guy right here. Let's bring that down and measure it just so that we're kind of talking apples to apples and oranges to oranges type deal. Make sure that everything's kind of cool. So both of those, both the bias voltages in on this particular sensor are sitting in at about 6.2 volts, give or take a little bit. When I look at the test voltage, or what I'm calling the test voltage, it's the computer's monitoring voltage, I guess. both sitting at about 11 volts. So I don't see anything voltage-wise that would indicate a problem here. And I'm just going to go in, take a closer look at these guys, see if there's a difference in the pulse. And again, I don't see anything here that would indicate that I have a fault, and yet the computer is definitely faulting the purple trace, or this trace right here. So I'm going to do two things. Number one, I'm going to move my test leads right out to the sensor itself to make sure that I have the same signature at the sensor that I do at the module. Obviously, if there's a difference in signature between the two test points, then I've got a wiring issue between the module and the sensor. Now, if they're the same, that obviously means that the computer's looking at this in a different way than I'm looking at it. I'm looking at it as straight voltage signature. The computer obviously must be looking at something else, because for all intents and purposes, the voltage signature, at least when you turn them on, looks to be pretty normal. So I'm going to go ahead, and what I'm going to do next is I'm going to test the left front circuit right at the sensor, just to make sure that I'm not missing anything out there. Very quickly, what I did here was literally I moved my green trace out to the sensor itself. And what you're looking at here in the green trace is the signature on the signal wire at the sensor, and the signature of the left front sensor at the module, the airbag module. I'm just going to zoom in on this a little bit. And very, very quickly, the signature is exactly the same at the sensor that it is at the module. Therefore, I don't have any kind of a wiring problem with this vehicle. The wiring is fine. So now I need to kind of reevaluate, if you will, exactly how the computer is determining whether this thing's okay or not. And literally, the computer has no way to test the resistance of the circuit. So there's really only two things it can look at. One of them being voltage, which is most common thing that's monitored or measured by a computer to determine status of the circle. But the only other thing I can think of here would be current. So what I'm going to do is I am going to use a device called a MicroAmp Clamp. It's an inductive amp clamp that's used to measure extremely small currents, typically in the milliamp range. So what I'm going to do is I'm just going to hook my MicroAmp clamp up and test to see what the current signature looks like on a good sensor, and see what the current signature looks like on our sensor. And what I'm hoping to achieve here is hopefully the current sensor will tell me or show me a difference, and then from there I can start to make some decisions as to what it's going to take to fix this thing. So this is a MicroAmp clamp. It's capable of measuring down as low as 100 microamps. So it's a pretty capable little tool. Don't use it a lot. Not sure that unless you're doing a lot of electronic type diagnostics that there's really much use for one, but it's simply an amp clamp. Basically clamp the amp, clamp the probe around the wire. It won't take a very big wire either, I should mention that, but you simply clamp this around the wire that you want to measure, hook this up to your scope or your voltmeter or whatever you want to use. And it does have a scaling of 1 millivolt per milliamp. So we're just going to hook it up on the signal wire and see what we can see for amperage. And we'll do the good sensor and the bad sensor again, just so we know. And if we do see some kind of an amperage reading on the good sensor, then we know that that's one of the things that the computer is looking at. And then we'll move over to the bad sensor and see where we're at. So here we are now back at our right front sensor, and I did these right at the sensor just to make sure that we're getting readings at the actual component. So the blue trace here is my MicroAmp Clamp. This is my signal. We don't see the little break because all I did was turn the key on here. I'm just going to zoom in on this and give you a little bit of a better look, and then I'll show you what I'm looking at. Right. So basically, explained a little bit earlier that we're looking at about the conversion on our MicroAmp clamp here is 1 millivolt per milliamp. So when we turn this thing on and the computer starts to apply voltage to the circuit, we can see the amperage go up, and it kind of settles in at about well, almost 10 milliamps. So now I know that a good voltage signature, I know what it looks like, and I know what a good current signature looks like, about 10 milliamps. What I'm going to do now is I'm going to go in and take a look at the left front, the one that's given us problems, and see if there's any difference in the signals. So here's the left front sensor, same hookup, amp clamp around the signal wire, and the red trace is the signal wire. Now, I'm just going to zoom in on this. This is pretty straightforward. Then my computer will catch up here. But if you take a look at it, my voltage signature, same as before, but there's no change in the amperage. And all that means is there's no current flow in this circuit. So what I've got here is a situation where I've got voltage being applied, but no current. Now, the only way that can happen really is if the circuit is incomplete. So I know I don't have a wiring problem. At least I don't think I have a wiring problem. And the sensors are brand new and the computer's brand new. So barring everything else, that means either the new module screwed up, or I have an incomplete circuit, but it's not incomplete between my two test points, which only leaves the connectors themselves. So I think what I'm going to do is I'm going to pull the connectors off and take a look at the pins inside the terminals, which is an unusual failure, but I do believe that's where I've got to go next.
So what we're doing here is we're testing the tension on these pins. Our testing with the scope showed us that we have changing voltage here but no current. That pin's pretty good. That pin, I don't know if you can see it or not, there is no tension at all on this pin. Won't even hold my test pin in place. So it looks like we've got a spread pin at least in this connector. So I'm going to have to take this connector apart and see if I can't find another terminal for it, or maybe squeeze that one down.
So we went in and took a closer look at the connectors, found some spread pins. So what we did was we rewired the connector in the driver's door, left door, and we rewired the connector left front, the one above the RAV saddle. After we got it done, we went in and we tried to run the configure to module routine on the scan tool. The procedure went through okay. It completed. We went in and did a quick check on it for codes, and now the car is code clear. The airbag light is off. So the bottom line on this one really is we had spread pins in both the door connector and the front crash sensor connector right at the sensors themselves. I don't know how they got damaged. I suspect maybe somebody was testing them and used a pin or something that was too big. Anyway, the bottom line is car's fixed. It's down the road. And other than it took us a while to figure out how to test it and um, figure out exactly what we're looking for, it really did come down to a simple case of some bad pins in the connectors. They were repaired. The car is on its road. Great. Hope you guys enjoyed the short video, and we'll see you at the next one. Hey everybody, if you enjoyed this video, please don't forget to hit the like button. Please don't forget to hit the subscribe button so you subscribe to our channel. You can follow us on social media, shown on the screen here. And if you want more access to more in-depth training videos, more technical, longer, and subject-specific, please visit our website at www.autoaid.ca. Thanks.